is yours, isn't it? Not mine. This isn't even, and that's true. This is this, you know? He'll be looking for this. Okay. Okay guys, so to go. Page 64 now. Okay, so, listen up. What we're going to look at is equations that have log in it, or that we need to use log to solve. So just before we get into solving equations, we have to talk about when are our logs defined. So for example, if I wrote log base 4 x 2, something like this. For the moment, I'm not talking about solving this. I'm just talking about what values of x I can use. So we know that x here has to be positive, and it can't equal 0. This is what I mean by when I say, when is the log defined? It's defined if x is positive. What about if I put the x here? What do we know about x here? Can it be positive, negative, only positive, only negative? What do we think? Positive and negative. Could it be 0? Yeah. So here, this log is defined for all values of x. And then finally, here, what can I say about the x here? Well, it's usual to say the x must be positive, just like how we said in the first one here. So, I'm not solving anything right now. I'm just talking about what values of x I can use. Okay. Now, it doesn't have to be positive, but it's usual to make the base positive. And besides which, if I did a little bit of a swap here, I could change this into 1 over log 16x. And then you can see now that the x has to be positive. So we usually just say the base has to be positive as well. Okay, so now let's have a look at some actual equations to solve. So my first example is 5 power x equal to 4. And I want to know what x is. So what we could do here, we could put a natural log on both sides. And we can use the third rule, I think it is, that lets us take powers down in front of logs. So we get x log 5 equals log 4. So then x equals log 4 over log 5 is the answer. Can someone just give me that number, please? 0.9, is it? 0.86? Okay. So that's just a small one to get us started. Okay, let's look at one more difficult now. Do you have this taken down? Do you have this? Yeah? Okay, so let's look at one a bit more difficult now. So for example, I have 4 power 7x minus 7 equals 7 minus 3x minus 6. So just like before, we can put a log on both sides. And just like before, we can take these powers down in front. So now I get 7x minus 7 log 4 equals minus 3x minus 6 log 7. So the powers came down. Then what I can do is I can open both of these up. So I have 7 log 4 x minus 7 log 4 equals minus 3 log 7 x minus 6 log 7. So you can see that there's an x piece here and here, and then there's a non-x piece here and here. So if I bring my x's to the left, I get 7 log 4 x plus 3 log 7 x equals 7 log 4 minus 6 log 7. And you can see on the left that x is in common to both. So now I can say 7 log 4 plus 3 log 7 x equals 7 log 4 minus 6 log 7. So we're just one line away from the answer. X equals 7 log 4 minus 6 log 7 all over 7 log 4 plus 3 log 7. Yeah?
Minus 0.1.
Minus
1. Minus 0.127.
minus 0.127.
That's 2 decimal places. So
Minus 0.13 then to 2 decimal places. Okay. Can I go down to another one?
Yeah.
Yeah? Okay. So for example, 9e2x minus 3ex minus 6 equals 0. So you can see the first thing I can do is divide everything by 3. So I have 3e2x minus ex minus 2 equals 0. So dividing everything by 3. And then when you look at this, you realize it's a quadratic. 3ex squared minus ex minus 2 equals 0. So if I use well, I could try to factorize it, but I can just use the formula. Ex equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So you get ex equals 1 plus or minus 5 over 6. So if I took the plus first, that would be 1, and if I took the minus second, 1 minus 5 is minus 4, so it would be minus 2/3. So I get ex equals 1 or minus 2/3. Now one of those answers I have to reject. Yes, why? Yeah, give me more. Why do I reject the minus answer? Yeah, but why? What's the problem with it?
Because you don't have anything to compare it to.
Well, simply put, ex is always positive. So this doesn't make sense. We can't find an x that makes ex a negative number. In other words, this is an impossible situation. It'd be like saying x squared equals minus 1 or sin x equals 2. These things don't happen. So we reject. And we can continue here. So what we can do is, you could probably see that the answer is 0. You can see that it's e power 0 makes 1. But if you didn't see that, what you do is you put a log on both sides. So you get x log e equals log 1. Now what's log e? It's 1, yeah. And what's log 1? 0. So you get 0 then. Okay, can I scroll down? Yeah. Now I'm going to show you some very useful results here, and it might be a bit surprising if you haven't seen it before. But if I take any type of power function like this, 2 power minus 9x plus 4, it's always possible for me to write it in this form: a e bx. In other words, I can always rewrite something that has an x in the power in this form. And this is good because this form here is often much more useful to you than in this form. So we don't like this form, but we like this form. So the question now is, how can I find the a and the b to rewrite it? So let's have a look at that. So the first thing I can do is, at least I can take the 2, 4 out in front, like this. So that would be 16, 2 power minus 9x. And let's just leave it up the top here. We're trying to get to something that looks like this: a, e, b, x. So the next thing you can see is, well, the x is going to be on the outside, so we might as well do that. sorry, x. Like this. Now I just need to go to the side for a moment. So if I just go to the side for one moment, notice if you have log ex, that's equal to x. Because you can take the x down, and what's log of e? It's 1, so that's true. And likewise, you could also say e log x, that's also equal to x. So for example, if you had log e 5, that's equal to 5, or if you had e log 5, that's equal to 5. In other words, an e and a log together cancel each other. So that's important to know for what I'm about to do next. I can change this into 16 times e power log 2 power minus 9. So if you can see that, what I did was I put this here with an e and a log in the front. E and log cancels, so I haven't really changed it. If you type in e log 2 power minus 9 on your calculator, you get 2 power minus 9. I can clean this up a bit. This is 16e minus 9 log 2 x. And then finally, the x can multiply in. 16e minus 9 log 2 x. By the way, what is minus 9 log 2? What is it?
6.2.
Minus 6 point, give me another place. 2/4. Like this. So what you've done is you've managed, well, it's up the top here, you've managed to change your original into this form. And these two things are exactly the same. For example, if you put in here x equals 0, you get 16. Now, if you put in here x equals 0, you also get 16. So they're exactly the same, but this form is more convenient to us, and this will become more important later in the semester when we do calculus, and then in semester 2 as well. Okay, so it's an important skill to have, to be able to change something that looks like this into something more usual like this. Who here has done calculus before? Some people have done calculus, yeah? So for the people who have done calculus before, do you know what the derivative of e5x is? 5e 5x, okay? But if I said the derivative of 5x, you don't know what that is. Anyways, my point I'm just making again is, it's much more convenient to have e instead of some other number. Okay, let's look at the last example here. Yeah. So our last type of problem So here we want to solve this equation. Now, if you look at the end of the page, I give you many different types of log equations. So the way to solve this is going to be different each time. You're going to need to use your rules of logs. And what rules to use, you won't know until you see the question, okay? But before I start, I should always write down for what values of x are my logs defined. So firstly, I must have 7x plus 5 bigger than 0, and x plus 2 must be bigger than 0 as well. This means x must be bigger than minus 5 over 7, and x must be bigger than minus 2. Therefore, I don't need to write both of these. If I want both of these to be true, which one must always be true? So which two? Which one?
Minus 5 over 7.
Thank you. Yep. So if you look at the number line, you want x to be bigger than minus 2, and you want x to be bigger than minus 5 over 7. The only way both of those things can be true at the same time is if x is bigger than minus 5 over 7. So whatever answer I get, it must be bigger than minus 5 over 7. That's important because it's possible that you'll get two answers and you need to choose the correct answer. We must choose the answer that's bigger than minus 5 over 7. Okay. Right, so let's have a look at solving this now. So we have, well, what's the first problem with this? Different bases, yeah. So which base should we change? The 36 to 6. So we get log 6, 7x plus 5, all over log 6, 36, minus log 6, x plus 2 equals 0. Okay? Oops. Log 636 is 2. So this is a half log 6, 7x plus 5 minus log 6, x plus 2. Okay. What do you think I should do next here? What do you think I should do next? Any ideas? So should I do something with the half, or should I bring the log to the other side? What do you think? Yeah, if you want, this half can be moved up to the power. So you get log 6, 7x plus 5, power a half, minus log 6, x plus 2 equals 0. Okay, what's next? You have two choices here. Yeah, we can take this to the other side as one of the choices. Or we could have used the second rule of logs. Okay, what's next? Yeah, what's next? Someone said it there? Cancel what, yeah? We have a log 6 on both sides, so we can cancel it. And we're left with this. Okay, well you know what power a half is. What's power a half? It's square root. To get rid of this square root, what should we do? Square both sides. 7x plus 5 equals x squared plus 4x plus 4. So you get x squared minus 3x minus 1 equals 0. So now, this doesn't even have factors. We have to use the formula, don't we? Did I do something wrong here? Problem? Do I say anything about decimal places here? Yeah, no, it's a decimal. So it's minus b plus or minus the square root b squared minus 4ac all over 2a. So you get two answers. 3 plus root 13 over 2 or 3 minus root 13 over 2. And what's this as a decimal, please, these two? 3.3.
Minus 0.3.
Yeah? Now, let's go back to the start for a moment. If you remember, I said x must be bigger than minus 5 over 7. Which both of these are we 100% sure about this? Or maybe I do take both answers. Let me have a look.
Yes.
Oh yeah, no, we do take both answers. So in this example here, both answers were acceptable. So we accept this answer and we accept this answer. Sometimes we have to reject one of the answers. Not so in this case. So we have two answers. I'm actually going to do another example for you. Can I scroll down for the next example? So we have log x2 minus log 2x equals 3. So you see, the first problem is the bases aren't the same. And this is an interesting one because the base actually, one of the bases isn't a number. Just before I start, I should point out that we can see that x must be positive. Okay, so what should we do with the base? Which one should we change? 50-50 chance. It doesn't actually matter. We just need to change one of them. I'm going to change the first one. And the way I'm going to change it is by flipping, by swapping the 2 and the x. I think this is the fourth rule of logs, maybe. So this is 1 over log 2x minus log 2x equals 3. So what I did was I swapped these. Now if you look at this, you could do something like let u equal log 2x. So this becomes 1 over u minus u equals 3. Now you've seen something pretty much the same as this before. What should we do next to solve this? Yeah, we should multiply by u. So we get 1 minus u squared equals 3u. Or in other words, u squared plus 3u minus 1 equals 0. Now this is a quadratic. So you have u equals minus b plus or minus the square root of b squared minus 4ac all over 2a. But let's remember what the u is. U is log 2x. So you get log 2x equals minus 3 plus root 13 over 2, or log 2x equals minus 3 minus root 13 over 2. Now to find the x, we just need to remember what log means. Log means 2 to this power is x. 2 to this power is x. So we can say x equals 2 power minus 3 plus root 13 over 2, or 2 power minus 3 minus root 13 over 2. Can I have these as decimal, please? 1.23, 0.1. Okay, 101 then. Do we accept both answers in this case, or do we reject any of them? Accept both, because at the start I said we need x to be positive from this. So both of those are positive, so both of them are acceptable. Okay, so what I'd like you to do is the last 5 in each. Last 5. And as you're doing these, I want to have a look at your homework that you've been doing recently. Okay, so just have your homework ready. I want to see what you've been doing recently. And it's the last 5 from each.